So hi everybody, my name is Ian Molloy. I'm one of the product managers at Autodesk, responsible for parts of Revit, and mainly MEP for my sins, and also the building performance analysis suite of tools. So I'm based in Boston normally, and since COVID, I've been able to get home more and remote work. I'm able to be home a lot now, so it's great, and it's great that this coincided with this event, so I'm really happy to be here. Just a little bit of background. One of the great things about being a product manager at Autodesk, you meet a lot of customers all over the world, architecture, engineering, construction firms all over the world, and a lot of partners as well, a lot of people working on the Autodesk Development Network and the Forge platform, developing third-party tools for Revit. Finesse Pro stand out in my mind from a large bunch for a couple of reasons. One of them is no doubt the Irish connection. I met Dave and Simon in Boston about 8 or so years ago when they're just getting started, and that immediate connection, just communication is just easier, right? But the other thing is the fact that they've identified some really important problems to solve. The idea, the role that facades play in buildings is such a huge impact on both the operational embodied carbon that Oliver just touched on is really important. And there's a lot of data needed to sort of make the right kind of decisions around that. But then the third thing that really makes them stand out is in my mind, is the fact that they are very open and listen to the practicalities of working with Revit. I'm sure many of you work with Revit on a regular basis. It's a kind of a beast of a tool, right? Very complex tool, used in a lot of different ways. There's an API, and a lot of developers approach it very kind of, single-mindedly. They have an idea for an app, they know how it's going to build, they've read the API, and but there's so many aspects. Does it work with work sharing? Does it, there's so many different things to consider. And throughout the whole process, as we provided Finesse Pro with some guidance, they really listened, and they've really adapted, and they've listened to their customers around, what is it going to take to make this easier? How can we make the tool better? How can we really get the tool in more people's hands to start making a difference on moving the needle relative to, things like energy and carbon? So I really applaud them on that, on really being agile, listening to their customers, and working towards making their tool better and better all the time. So I'm going to touch on energy analysis techniques in Revit, really sort of more a toolscape. In the time that we have, I'm not going to get into picks and clicks and things like that. I just want to make you aware of the tools that are sort of available to you today through your sort of, existing Revit Autodesk subscription. I'm not here to sell you anything. You already have these tools, which is great. And so I'll just give you a little tour. A lot of people, there's this sort of running joke between myself and some of the salespeople at Autodesk that some of these building performance analysis tools are the best features in Revit that you never heard about. Because, there's a lot of other things that, catch your attention. BIM 360, things like that. We've been, marketing that a lot. There's huge benefits in that. But there's a lot of value in here that a lot of people aren't actually aware of. So there's tons of different building performance analysis tools out there. Literally, there's a list of them. Many of them go back decades. I'm really just going to talk about the ones that Autodesk developed to try to, add additional value to the design process. And you can really break it down into 3 parts. There's Revit, and Revit itself, what it does. Then there's insight and systems analysis. Just hands up here as who here have heard of those 2 things in some form or another. So about a third, less than half. So that's pretty consistent with my, best feature in Revit you never heard about, right? So I'm going to describe each of these, the sort of the role they play and how they work with one another. So Revit itself, you think about Revit, predominantly people are using it for documentation, coordination, and then sort of more increasingly in recent years, we've seen it being used in detailing and fabrication. Particularly in my world of MEP, it's been fascinating to see that evolve, really starting to see contractors start to manufacture from the model now. It's really quite amazing. But Revit also has the ability to create what we call an energy analytical model. It's a little bit of a, people usually use the word energy model. But we term it, that's just so we can sort of differentiate a little bit. And really what it is, it's the sort of the core geometry dimensions that are needed in order to simulate heat transfer, right? Heat loss and heat gain throughout the whole building from space to space, so that from that you can actually predict energy usage. So there's a feature set in Revit that goes back actually over 15 years now that have approached this in a variety of different ways. And I'll say for my 12 years at Autodesk, I apologize for the kind of trail of destruction that we've left along the way of we tried this way and it didn't really work, and we tried that way and it didn't really work. But that's software development. You're learning as you go and you're seeing what works for people. Some people have adapted the workflow, other people have sort of given up because it's too complicated or they can't get the quality of the model that they want. It's not as automated as they need. But we continue to improve it. And today there is a suite of tools that really can create this energy analytical model directly in Revit, really in sort of two fundamentally different ways. One is directly using the model. That's sort of the most challenging thing because it depends on the quality of the model. We can get into the whole air tightness conversation and all that kind of thing later on. But then the other is to kind of create a separate copy of the model. Both have sort of like different pros and cons, different benefits, and they're really dependent on your skills level and how you want to really want to work. But within that, you can do anything from really recreating an entire model from scratch, just a few boxes to represent the building, or if you really start to understand how some of these features work, you can really start to automate how that is done. So really from as soon as you start to have any sense of a building site and some sort of building form, you can start to capture the shape of the building, start to analyze it. And that information is more than just geometry, right? There's a lot of information that Revit can actually host and be fed into the energy analytical model, which are things like material thermal properties, like density, capacity, U values, things like that, as well as building and space type properties, occupancy, lighting, equipment, internal gains, and so on. All that information is all embedded in that model. So there are tools available to you for creating that. The usual workflow would be export a DXF and create another model in a third-party tool. That's kind of been the MO for many, many years. But if you're familiar with Revit already and basic modeling with Revit, it takes you about a half a day to really learn how to do this pretty effectively, right? Now, using that model in, we've got really two main tool sets or features in Revit, if you will, that you can actually do to run energy analysis. I put that in sort of inverted commas just because, it's a very broad statement to say that energy analysis comes in a variety of forms, right? The simple way I kind of differentiate the two of these, inside is like the telescope. You're looking at the building, big picture from sort of far away. It's very sort of broad brush, and it's really intended for high level kind of targeting and sort of seeing those big trade-offs. And then systems analysis is like the microscope. It's much more detailed, much more precise. It's more like traditional energy modeling, and it's very detailed, very advanced, very much focused on sort of more the systems simulation side of things, and so on. So I'll just sort of broadly just sort of characterize a few of the pieces of these and how they're different and how they kind of work together, as well as how they contrast to and complement Finessa Pro. So first of all, with Insight, the main goal for us was that this really evolved over many years of research of what will it take, what information do we need to put in front of, let's say, an architect or even a client that will help them understand where they're currently at in terms of energy use and energy cost and what will make it better. And how can we provide something very visual, interactive that, they can see what the sort of cause and effect actually is. So when you see Insight, you see this like simple little nest looking dial that red, orange, green, red is bad, green is good. There's certain benchmarks built into it that are a little US centric, but you can still, the physics are still the same, right? Heat loss, heat gain still work the same all over the world. But the critical thing is it doesn't just do a single sort of simulation. It runs a whole bunch of different simulations in the cloud. It uses a kind of a legacy engine, Do2, but it's still very reliable. And it provides an energy range. And this is kind of unique in the world of energy analysis tools because what it does is it's not providing you with a single output. Sure, there's one number there, but it has a mean, a min, and a max. And the slope of those little curves there are basically what's indicating the importance, the relative importance of that factor. So you can see, for example, if you're looking at the level of insulation in the wall, at some point, as you keep adding insulation, you'll get law of diminishing returns. So you can see where that is at the same time as maybe what impact would improving the efficiency of the HVAC systems, what impact did the hours of operation make, and things like that. And what's unique about this is that allows you to embrace things like uncertainty. I mean, I was really fascinated to see some of the information Oliver shared there about the difference between a design or specification of your U value and then the actual U value. We're led to believe that, the specification is fact. When it comes into reality is that there's a lot more unknowns about these buildings and models that we don't know, and we need to kind of embrace that uncertainty and design it out of the equation as well. It also includes things like benchmarks. So you've got things like ASHRAE 90.1 is the code standard that's used in this, which again is a US standard, but it kind of has some place in the world of just understanding that it's some reasonable level of efficiency beyond which you can start to understand if you're doing better. And people often confused about this. This runs in the cloud. It's included with your subscription. It doesn't cost you anything to run. You can once you've got your analytical model, you can press the button, you can send it to Insight, and you'll see these little dials that you can move around and start to dial in what your current sort of maybe baseline option is, and then explore some scenarios with it. So it's meant to be very interactive. Really, one of the best success stories we've heard, particularly from architects, is that they actually open it up in design team meetings to show owners, if you make your windows bigger, you're going to use more energy. If you derate the glass, you're going to use more energy, right? But if we make the windows smaller, we use better glass, or we add some shading, here's where you'll see what the energy use impact will be on that, and it puts it in sort of real world terms for them. Systems analysis is kind of like a different kettle of fish. Like I said, it's more like a traditional energy analysis tool, whereas it takes the individual Revit model, whatever information you've added to it, same information that's used in Insight, the envelope and internal loads and things like that. But what systems analysis allows you to do is to detail the mechanical systems and electrical systems in a lot more detail. So you can define, you've got heat pumps or VAV or fan coils, whatever your central plant is. And then it runs an Energy Plus simulation through the Open Studio SDK, right? And the real power of that is it means that the whole simulation is a glass box. It's not a black box, right? Everything that's run through that simulation is specified through a series of what are called measures or just scripts. And so anyone who's used to using Energy Plus or Open Studio, which is like a freeware developed by the US Department of Energy, but is not US specific, right? It runs in metric, it's building physics, it works all over the world. But this is now integrated into Revit so that from that model, you can run that. And it really provides two major use cases. One is that on the sort of like more basic mechanical design side of things, it allows you to do your loads and sizing, which can also feed into the downstream physical modeling. So if I've sized a bunch of heat pumps and now I want to place them in the model, I've got the information on what the sizes and the capacity of those systems should be. Then I can simulate that system because I've got the information there to simulate that. And that provides the more classic, end-use breakdown kind of output that you'll see from a typical kind of energy simulation, whereas Insight is purely focused on the key metrics. Systems analysis provides more of a detailed breakdown of a single sort of snapshot or point in time and so on. So they're the kind of really two tools. What's really interesting is about, Simon has done some examples of this in the past about, particularly with Insight, how Insight and Fenestra Pro work well together, because with Insight, it's very high level. Everything is kind of pretty generic. You're talking about levels of installation, levels of efficiency in HVAC systems. But Fenestra Pro can go into a lot more detail on the facade, on the quantities, the dimensions, materials, and things like that, as well as things like certain metrics like solar gain per square, I was about to say foot, square meter, things like that give you additional information, additional metrics that you can design your building towards, which are often used in a lot of building codes and regulations for pure compliance purposes. And I share again Oliver's sentiment about how much compliance sucks, right? It's like it's such a costly thing to do, and it doesn't actually really save anybody anything. So yeah, they complement each other a lot, and we've done a couple of examples over the years to show how they can work together, because critically they use the same model. All right, so that's what's available today. Everything you've seen there is available today. If you've got Revit 2023 installed, you might just find that the energy analysis tools are disabled. Go into your file options, open up energy analysis, and you'll see Insight is enabled. There's plenty of information online about how to use those tools, a couple of classes and so on. What I want to talk about now very briefly is just we're continuing to develop these things. Everything I've shared there is, we've been developing. Autodesk is a relatively new entrant to the kind of building performance analysis space. We're kind of traditionally a design documentation company. But since we acquired Ecotech and Green Building Studio and sort of wrapped them into Insight and things like that, we've continued to invest. And as the market embraces these tools, we're seeing more and more architects using these tools, we invest even more. So there's a couple of things that are we've already kind of publicly announced. If you're a big-time Revit user, you should check out the Revit blog and check out the public roadmap. Every quarter or so we update things that we're working on. And one of the big ones that you'll see soon, I won't promise anytime soon because I've got to be careful about what we promise and stuff like that being a product manager, but there's a feature on that list you'll see about create the energy analytical model by elements in a view. Sounds like a very small thing, but it's a radical shift in how much easier it will make creating the model analytical model directly from the model rather than having to work through copies and things like that. So it's a simple little change that will make a big, big difference in terms of creating your analytical model from your live Revit model. Normally we see people having to create side copies because there's inconsistencies in the way the thing needs to be modeled and so on. So there's a little thing happening there on Revit that you should see sometime soon. And then on the Insight side, if you've been using Insight for any period of time, you'll see that there hasn't been much active development in the last couple of years because we've been very busy on developing what we kind of call next generation. So Insight today, being one of the first kind of cloud-based tools that Autodesk kind of acquired, was built on some legacy cloud tech, directly on AWS and so on. And so now everything in Autodesk is built with Forge. There's layers of not only security, but performance and different things every cloud service needs to go through. So we've had to really rebuild Insight up from the ground up. It's now, we've dropped Do2 and it's now fully Energy Plus and Open Studio. And the really key thing that we've set our sights on is, Insight today provides insights on energy use intensity, energy cost. But the key thing that we're focusing on now is total carbon. So that's taking the operational energy analysis and with that same information, whatever information we have in that model, use as a starting point for the embodied carbon. And for that, we're drawing information initially from EC3, but of course we expect people to add their own information to the model and to Insight to be able to enhance those insights. The real goal is to start to, with embodied carbon, when you get past the kind of the major pieces of things like structure and slabs and where there's a ton of carbon, you start to get into these integrated systems parts, like, you go from double to triple glazing, okay, that's going to save you some operational carbon, but there's an embodied carbon cost of that as well. What's the right thing to do there? Right, and especially early stage, if you're also changing the window wall ratio, there's clearly an optimization that needs to be done there to guide people in the right direction. So we're trying to provide the information both in Revit, and Insight kind of acts as the sort of like a standard starting point for everybody to start to understand how you can do this in a repeatable way. We're seeing lots of people develop different kind of carbon spreadsheets based on different quantity takeoffs in the model, but there's some challenges there with, well, how is your model built? Is that a repeatable, reliable takeoff that you can do? So that little link down the bottom there, you'll see if you want to take that, you'll go to a blog post with a little bit more information about that. And then finally, if you want more information on really what we're doing in this space, at the last Autodesk University, we did this class on what we call total carbon data analysis and insights. And it kind of explains the why of total carbon, but also, the what and how of this concept of you don't just need analysis, you need this idea of there's data, you need to analyze it, and then you need to bring it meaning. You need to give understanding, as Oliver was pointing at. And that's really what we're trying to formulate as the user experience and platform that we're creating for data with Next Gen Insight to sort of enable everybody here in this room and around the world to start to have better conversations around the total carbon question.